Okay, cool. So we are on section 8 of L&L's classical mechanics, and section 8 is titled The Center of Mass. Now, the momentum of a closed mechanical system has different values in different inertial frames of reference. If a frame K prime moves with velocity capital V relative to another frame K, then the velocities v prime and v of the particles relative to the two frames are such that v equals v prime a plus v. So we have two frames, k and k prime. In k prime, our velocities are va plus capital V. And the momenta p and p prime in the two frames are therefore related by this equation. So we have p equals the sum over a m a v a, which is correspondent to the sum over a m a v a plus capital V sum over a m a. Because p equals mv and v is v plus capital V. Now, in particular, there is always a frame of reference in K prime in which the total momentum is 0. So if I write P equals P prime plus V sum over A M A, and if we set P prime equal to 0, then we can denote the following, that the velocity of the system, or capital V, is equal to P over the sum over A m A. And this can also be denoted as the sum over A m A v A over the sum over A m A. If the total momentum of a mechanical system in a given frame of reference is 0, it is said to be at rest relative to that frame. This is a natural generalization of the term as applied to a particle. Similarly, the velocity capital V, which is given by this equation here, is the velocity of the motion as a whole. And from here, we can see that the law of conservation of momentum makes possible a natural definition of rest and velocity. Now, this formula also shows the relation between the momentum and velocity. And it's also very similar, it shows very similarly the relations of momentum and velocity as momentum for a single particle, because if we have p equals mv for a single particle, then v is just equal to p over m. And the expression on the right hand side here, we can just denote it as the total derivative of our r vector, which we can define our r vector as the sum over a m a r. And to equate this, we just also divide by the scalar sum over a m a, which if we take the total time derivative of this, we would just get sum over a m a v a over the sum over a m a, which is the equivalent expression we have there. Now, The law of conservation of momentum for a closed system can be formulated as stating that the center of mass of the system moves uniformly in a straight line. In this form, it generalizes the law of inertia for a single free particle whose center of mass coincides with the particle itself. In considering the mechanical properties of a closed system, it is natural to use the frame of reference in which the center of mass is at rest. This eliminates a uniform rectilinear motion of the system as a whole, but such motion is of no interest. The energy of a mechanical system which is at rest as a whole is usually called its internal energy, and I will denote this by E sub I, which is going to be defined as the internal energy of a system. The total energy of a system moving as a whole with velocity capital V can also be written as E equals 1/2 mu V squared plus E sub I. And this is capital V, and mu is just the sum over A ma. And this formula is fairly obvious, because if we have the energy of the system being equivalent to 1/2 sum over A MAVA squared, and this is going to be little v plus u. So we know that little v is equal to v prime plus v. Now, if we generalize it for the eighth particle, we get 1/2 sum over A MA VA prime plus capital V squared plus U. And expanding, we get 1/2 mu V squared plus V dot sum over A MAV prime A plus 1/2 sum over A MAV prime A squared plus U. And this is the only capital V in our system here. And simplifying this, we know that 1/2 mu V squared stays the same. Plus, we know that mv prime is just equal to p prime momentum. So this term becomes v dot p prime. And we also have that this term here is just the energy of E prime, because energy equals T prime plus U, and T prime is just 1/2 mv prime squared. So we have plus E prime. And if we were to choose a frame where P prime equals 0, then this equation just turns into 1/2 mu capital V squared plus V dot 0 plus E prime, and This term can just be omitted in the middle. So we have derived the original equation for energy up here, which if I call E prime the internal energy of the system, EI, they are the same formulation.